Welcome. Today's online video demonstrations will cover our first prototype, a TGS server. A TGS device is a router, switch, or server of any platform type with integrated thermoelectric technology. Thermoelectrics is a branch of science and technology that encompasses harvesting waste heat and turning it into electricity. Simply put, a TGS-based device harvests, recycles, or converts the waste heat energy from the components inside the device to generate DC electricity. This energy harvested can be reapplied to the same device to reduce its draw from the grid, or the same energy harvested can be reapplied to other uses externally from the device that harvested it in the first place. This segment demonstrates our external application of this use. In this segment of our online demonstration, we shall show you how one of our prototypes generates electricity. Our prototypes are based on a 1U server platform. We also have a switch version to show as well in another online demonstration in the future. A TGS router version also is forthcoming. Our prototypes run on the Windows 2003 server operating system and have utilities to generate a workload. Our prototypes also work with Windows 2008 server and Linux operating systems as well. As you can see, this server looks no different than any of your typical enterprise 1U rack servers, except for a couple of differences. The front of the server has a voltage meter to show you the energy potential levels in volts that the server is generating. The value shown here is in real time, meaning that as the system works harder and achieves higher utilization levels, more energy is generated. As the system works less, or is even sitting at idle, less potential is generated. In the rear of the unit, we have our direct current electric leads. These are the leads that can connect to a load, such as a light or small motor, to be powered or to be connected into another TGS server or power distribution system. We will demonstrate examples of additional servers being used to scale the energy generated in another segment of our online demonstration. This prototype is configured in unregulated power mode. This means there is no inherent voltage regulation or storage of the energy before the red and black leads and the front meter. The energy is dynamic and based on the operating behavior of the system. We intended to leave the system in this raw configuration to demonstrate the contrast of the amount of energy generated from minimal utilization and heat generated state to increased utilization and increased heat generated state. Simply put, the more work the system does, the more energy is generated. With the advent of new regulation technologies such as the LTC 3108 ultra-low voltage step-up converter and power manager from Linear Technologies, and the use of multi-farad electric double-layer capacitors, also known as supercapacitors, we can further harvesting efficiencies plus store more of the energy in a controlled manner per TGS device. Upcoming production versions of TGS products shall include such components. Okay, now for a basic demonstration of the TGS server in action. Here is our system in the idle state with a meter connected to the rear DC leads to confirm the volts generated from our front panel meter. we used one utility from Passmark software called Burn-in Test. This tool enables us to stress many components inside the server, thus simulating any type of workload which produces the heat resulting from such work. We also used a tool from our system manufacturer to monitor the system's environmental state, such as the fan speed, volts consumed, and temperature. As you may observe on this screen, we can set the utilization levels of the processor, disk, RAM, and other components to our desired levels. We set them to 50%. Now we shall execute our tests to stress the server in the 50% utilization range. As noted, one of our tested components, the CPU, is loaded with work. Notice the jump in utilization for the system and the increase in volts produced on the meter. Remember our system at idle producing almost 2 volts of energy? Now imagine hundreds of such systems or blade systems at idle producing this amount of potential energy. Again, imagine many such systems conducting their normal workload producing upwards of 5 volts each. This is now possible. With the advent of low power consuming components in servers today, our system and approach to harvesting energy is still very viable, for joule heat will always be present. Now when we stop the tests, notice the utilization drop as well as the amount of volts produced. What was demonstrated here is the basic unregulated operation of a TGS device. The more work a system conducts, the more heat is generated, thus resulting in more energy generated. The less work a system conducts, the less amount of heat is generated, also resulting in a lower amount of energy generated. We are also working with advanced nano thin film thermoelectrics to increase our harvesting capabilities inside a TGS device. There are many computing and power supply related components that generate waste heat which could not be captured in the past. However, these heat sources can now become a part of our system due to the nano thin film thermoelectric technology. Blade servers, high performance computing systems, switches, and various IT appliances are all candidates. For example, router and switch components such as 10 to 100 gigabit chipsets, codecs, and DSPs, and encryption ASICs, all which generate waste heat, can now be harvesting sources. Some examples include the ZenPack 10 gigabit Ethernet modules and something like the Cisco WAS modules or newer Nexus 5K, 7K modules, to just name a few. If nanotech technology can be applied into these discrete device locations and modules to harvest the energy before it is cooled, additional scaling or recursive uses can be achieved. IT components no longer just consume energy, but can produce as well. In our next segment, Anatomy of a TGS Server Part 2, we shall demonstrate powering some simple loads to show the unregulated behavioral aspects of our system when the energy is put to use. We hope you enjoyed our first segment and find our work exciting. For more information about our work, please visit our website. There is a white paper and slide presentation outlining our enterprise energy vision and the value of thermoelectrics in IT. Plus, the website has other videos and resources that provide details about the technology behind thermoelectrics and our system. Thank you.